webinar, Tunnel Liners, Re-lines and Rehabilitation with Patrick Bureau and David Groot. Today your host is Patrick Bureau, PNG, and I'm going to let Patrick take over from here and introduce David as well.
Hello everyone. I'll be speaking to you about tunnel liners and relines. My background is design of buried steel structures with Armtec. I have about 10 years experience doing that, and now I'm one of Armtec's business development engineers in Western Canada. With me on the line is David Groot, one of our senior sales representatives in Central Canada. He has a couple decades of experience with drainage products and about 14 years with Armtec. Just to give everyone a bit of an overview, if they're not too familiar with Armtec, we are a global infrastructure and construction materials company. We have over 40 locations across Canada, and in peak seasons, approximately 2,000 employees. So we offer a really wide range of products for applications ranging from infrastructure, marine, land development, and covering all the resource sectors as well. Just a quick overview of some of the range of products that we supply as a company. Anything from precast bridge materials to our large offering of drainage solutions and water treatment. Also, we manufacture and supply many landscaping products, noise barriers, precast building elements, as well as some highway and road safety products. And we also get into soil retention and underground structures. Moving on from that, I'm just going to give you an idea of what we're going to be speaking about, or what we're going to be talking about today. I'm going to split the presentation up into two sections. First, we're going to talk about just general trenchless concepts, focusing on tunneling and relining. And then we're going to actually get into the meat of the trenchless solutions that Armtec designs and supplies. So first, we're going to talk about trenchless concepts. And well, what is trenchless? Basically, trenchless is a type of construction. It's a subsurface installation that does not require open-cut excavation. Essentially, you're avoiding excavating or disturbing an embankment. So trenchless technology can be used for new construction, as in tunneling, which we're going to talk about, or also rehabilitation, as in relining. And we're going to talk a lot about that. So trenchless technology is a rapidly growing industry, and this is due to the many benefits versus traditional open-cut excavations. Just to give you a bit of an overview, aging infrastructure is also putting a huge demand on replacement and rehabilitation of existing structures, and this is really a driver for the growth of the trenchless industry. If you consider yourself possibly middle-aged, you can imagine, or you can picture that about half of Canada's infrastructure is older than you are. And also about a third of Canada's municipal water infrastructure is approaching or past its service life. So there are a lot of infrastructure in need of repair or replacement, and that definitely is a driver towards trenchless technology. And we're going to talk about why. So just to give you a pictorially comparison between a traditional open-cut excavation versus trenchless operation, you can see on the photo on the left, this is a very deep trench that's been excavated, and they're installing the utilities, and eventually they're going to have to fill that back up with compacted material. And that's quite an operation, especially the deeper you go. And consider that poor guy at the bottom of the trench. He's got to climb up and down that ladder all day. If we compare that to a typical trenchless operation, here's an example of a slip lining job, you can really save in terms of excavating and emissions and whatnot. And we're going to talk about that right now. So I'm just going to go over some of the benefits of a trenchless operation versus open cut. I'm just going to highlight the benefits. If you don't have to disturb the embankments, you're minimizing or eliminating traffic disruption. That's definitely a benefit there. There's also a reduced impact to the local environment in terms of dust and silts and whatnot. Anytime you don't have to be excavating, you really reduce the amount of contamination. And also the excavation and hauling of material, by reducing that, there's potentially a huge cost savings overall in a project. There's also the impact of the road surface. If you don't have to dig up the road, then your road surface is going to stay intact for quite a bit longer. But most importantly, I think worker safety is probably one of the biggest benefits towards using a trenchless operation versus an open cut. Worker safety and injuries and even death. It's a known problem, particularly in North America, due to the improper use of trench boxes or trench slopes. And that's something that really can be avoided if you don't have to do the excavation. And also, in some cases, you can keep the workers completely outside of the construction, and that really reduces the risk of injury. And lastly, I wanted to touch on the green aspect of trenchless operations. There is the potential to have an overall reduction in equipment and vehicle emissions. If you consider large excavation equipment, it doesn't need to be running. And there's also the moving and hauling of excavated material. There's a lot of emissions that can be avoided or reduced in these types of operations. And also consider that many municipalities across this country and across the U.S. as well, they're paying real attention to the overall amounts of emissions in projects, and eventually it will be a driver in terms of what type of construction is selected for particular projects. So we're just going to talk about one type of trenchless operation first, and that's tunneling. Tunneling is subsurface excavation, and we see it commonly used for a lot of construction and mining and infrastructure. Tunnels can be constructed using a wide variety of trenchless technologies, and these range from steel liners, which I've highlighted because we're going to be talking about that in terms of what Armtec can supply. There's also precast liners are very common. You may see those in large boring operations, and Armtec actually does manufacture and supply some precast liners as well. And there's more traditional methods such as sprayed concrete, commonly known as shotcrete, and pipe jacking is another common method for tunneling. So tunneling essentially is trying to get from one point to the next, but through the ground and in a new excavation. The tunneling process really is a staged excavation and installation process, and sometimes it is quite laborious. But just in very simple steps, I just wanted to outline, the very simplified process. First step is to excavate the tunnel as allowed per soil conditions, and I'll talk about that in a second. Once the tunnel is partially excavated, then it's time to install some of the liner, and then the next step is to pump grout or concrete between the liner and the excavated tunnel. And this is very important because the voids between the liner and the soils, they need to be filled so that load can transfer from the soil to the liner, and this is necessary so that your liner can act as a structural liner. And the soil conditions are really key when dealing with the tunneling operations. Soil conditions will determine for you what type of liner is feasible in the operation, and also how much you can excavate before you actually have to start installing the liner. These kinds of things are definitely require geotechnical or specialized tunneling engineer to determine the feasibility of a certain operation. And using contractors experienced in tunneling is also highly recommended. This is a really specialized type of construction. So just a couple of photos here. These are some nice, really old photos. These are actually tunnel liner plates installations, and these are they're excavating tunnels, and definitely a stage process. And you can see on the right they're excavating, and they actually have to install shielding before they can continue on with installing the rings and the grouting process. Tunneling is not always horizontal either. It can be vertical construction as well. And it's quite common, particularly small diameter shafts. As you can see in the picture on the right, that is a very large diameter shaft, about 30+ meters. That's actually our tunnel liner plate reinforced with W beams about every half meter, every ring. So definitely a wide range of applications that we can do with our tunnel liner plate. We'll get into more specifics with our tunnel liner plate in a minute. First, I also wanted to talk about relining. And relining is basically the installation of a new surface to an existing structure to provide either a facial or a structural restoration. So we could be faced with aging tunnels or culverts that could be experiencing cracking, spalling, or corrosion. And it may need a new surface to prevent further deterioration. But deteriorated structures, they may be in danger of failing, and they may actually require a fully structural reline. We're going to talk a bit about our options there. So generally, or commonly, a reline of a pipe or a culvert structure usually involves a slip lining process. And just very simply, the steps of that involve sliding a pre-assembled pipe liner into the existing pipe, the host pipe. Then setting up some bracing or blocking to hold the structure in place. And then pumping grout between the new and existing structure. So the bracing and blocking sometimes are important depending on how flexible your liner is. Grout will cause flotation within the existing structure, so very important to look at those before doing a reline operation. And same as with the tunneling process, grouting the void between the new and the existing structure is very important in order for that liner to perform as a structural liner. Again, the loads must transfer from the soil to the liner. And you'll find that a lot of the products that we supply, we design them as a structural liner, and they're usually designed as if the existing, impending failing structure isn't even there. So definitely a structural component. And I'm going to highlight that our flange liner plates can also be assembled in place. So first we're going to talk about using them in tunneling, and then also in relining as well. So just a couple of photos here of a couple of reline projects. Some of these are both relines of existing metal culverts that have reached the end of their service life, as I like to say, rather than rusting away. We like to sell those steel products as well. So on the left here we see the crew is sliding a corrugated steel pipe into place, and on the right you can see a structure that has been slid into place, and the bracing is getting prepared for the grouting process. As you can see in the photo on the right there, there are what we would call screw jacks, and these are a type of bracing that's actually shop installed. So we actually provide that with the pipe, and they will help the pipe stay in place during grouting when they're pumping the grout. So we talked about grouting and how important it is. A couple of options depending on the length of the pipe and the size of the pipe in terms of how to get the grout in there. Many times or commonly we do supply a shop installed grout port, which is essentially just a threaded coupling that's shop welded to the steel culvert or the steel liner, and then a threaded plug is provided so that it can be unplugged. The grout can be pumped in and then closed once the grout is filled the voids. So we just talked about tunneling and relining, and now we're going to move into the meat of it, and we're going to talk about the trenchless solutions that Armtec supplies. So just to give you an overview, and we're talking about pipe and culvert solutions, because this is the most common scenarios that we face with these types of products. We talked about open cuts, excavations, and it can be used. That type of operation can be used for both, new construction or replacement of pipes. And while we're promoting trenchless in this presentation, we don't want to slag open cut excavation too badly, because Armtec obviously supplies a really good array of pipe and culvert solutions for that type of operations as well. Well, we're going to focus on trenchless, and we were talking about tunneling, which is essentially normally used for new construction, as we're going to highlight our liner plate. And then we're going to talk a lot about relining in terms of rehabilitating existing structures, and the array of products that we provide that can solve those problems. And we'll be going from structural plate to grouted pipe liners, both steel and plastic, as well as some relatively new technology in some spiral wound pipe. So I'm going to split up our products into basically two categories, metal and plastic, and we're going to talk about those products that I just mentioned. So there's a structural plate and corrugated steel plate, or CSP, various plastic pipes, both HDPE and PVC, and at the end we're going to get into that the new technology, spiral wound pipe. So first I'm going to talk about structural plate. Generally when we're talking about relines and tunneling, we're usually talking about multi-plate or tunnel liner plate. But there are other structural plate options out there, including a deep corrugated structural plate, which is bridge plate. I'm not sure if everyone's familiar with that. But, so what is structural plate? Well, essentially it's a corrugated steel plate that's shop curved. So then when it is bolted together, it will form a shape required for a culvert or structure. So the individual plates are corrugated and curved in the shop, and they're bolted together on site. So multi-plate is commonly used for relines, and you can see on the photo on the left, this is actually a reline of an existing multi-plate, and which has reached the end of its service life, and it's being relined with a polymer-coated multi-plate, and we'll talk about the coatings in a minute, but the hope there is that the polymer-coated structure is going to last quite a bit longer than the existing structure did. On the right is highlighting our tunnel liner plate, which is also relining an existing particular plate is actually aluminum, and we're going to talk about aluminum plates as well. We're going to get really much more detailed on tunnel liner plates in a minute. But I just wanted to show you some after pictures. So these are actually the after pictures of the previous slide. On the left is the polymer-coated multi-plate reline, and on the right is that tunnel liner plate reline, and it's just about finished. It's finished grouting, and you can see that the bracing is still in there. So I just want to highlight the comparisons, and differences between standard structural plate, the multi-plate, and tunnel liner plate. Essentially, they're both bolted corrugated plates that are assembled, bolted together. The multi-plate, however, it must be constructed outside of the host pipe and then slip lined into place. Whereas the tunnel liner plate is actually, it's called a two-flange liner plate, and it has features that allow it to be assembled from the inside. So that's the key difference, and that's why it is a lot better geared towards trenchless tunneling and relining as well. So both the types of structures need to be grouted in place, and they're both commonly or can be designed as a structural liner, and they can be used to reline, various drainage pipes, water crossings, underpasses as well. But the tunnel liner plate also has the benefit of being able to be used in tunneling operations as well, which we talked about earlier. Multi-plate and other structural plate is available in standard, round, elliptical, and arch shapes. And similarly with the tunnel liner, wide variety of shapes are available, but we also do quite a bit of custom shapes and to fit a wide variety of applications. And I'll show you some nice pictures of those later. Just a couple of more photos just to illustrate some structural plate structures. These are relines. They're being assembled on the left. You can see the multi-plate structure is being assembled, and you can see how it has to be assembled on the outside of the structure before moving it into the host pipe, because the crew needs to be on both sides of the plate in order to make the connections. Whereas the tunnel liner, and I'll show you how in a minute, is quite adept at being assembled from the inside of the structure, and you can see in that picture that there's actually lift equipment driving through that pipe during assembly.
We've had a good question come in here. Are there minimum size requirements for structural and tunnel liners?
Well, the minimum sizes basically depend on, number one, being able to have the crew install or assemble the structure, whether it's inside or outside. So a tunnel liner, you kind of want it to be a little bit taller than 5 feet, so you don't need to hire a really short construction crew. But the actual fabricated minimum sizes, they are based on the minimum curving radii for the plates. So for a multi-plate, you're looking at a minimum of about 1,500 diameter, and I think the minimum for a tunnel liner plate is about 1350 in diameter. Okay. So moving on. So we talked about structural plate, but we really want to highlight tunnel liner plate because of its easy adaptation to tunneling and relining. So I mentioned that the tunnel liner plate is a two-flange liner plate. And you can see in the photo on the left, the flanges are the flanges around the circumference, and these are on the inside of the structure, so the rings can be bolted together from the inside. The sizes of plates range from, I think, 1,200 to about 1,400 in length around the circumference. But the width of the plates are actually about a half, they're 500 millimeters. So they're actually quite easily handled. Steel plates can be carried by a single worker and held into place by at most 2 workers. So they're very adept for assembling in a tight space. And if we're talking about aluminum plates, they're actually, contractors really like working with the aluminum tunnel liner plate because they are light enough to be handled by a single person. And also going back to the width of the plates, being only 500 millimeters wide in each ring, even though the lap connections and the hardware that's supplied with it are designed so that you don't need to be on the outside of the structure to make the connection. Being only 500 millimeters wide, there is still the option of reaching a hand or an arm in there to facilitate a finicky connection. So just moving on to the picture on the right, showing a grouting operation. This is actually WOW grouting. And you can see, similar to the picture before, we're just using a shop-installed grout port. And very common for, especially for large relines.
There was a question here, we might have covered it, but is the grout actually required for structural integrity of the tunnel?
Yes, absolutely. In order for the structure to actually take load, the load has to transfer from the soil to the liner. So the grout and the void need to be filled and completely filled with grout or concrete. There may be some applications where only a facial reline is required just to protect the existing structure. If the existing structure is still structurally capable, then you may not need a full grouting, but definitely recommended for a structural reline.
I have another interesting one. Are there options for relining box culvert systems with rectangular openings?
Yeah, we're going to actually show you some nice pictures because I'll have to be honest, we definitely do love to reline old concrete structures with our steel plate. So we'll show you that in a minute. So just moving on, talking about the assembly, just a couple of photos to really highlight the ability to assemble a tunnel liner plate inside an existing structure. On the left, you can see the contractor is just beginning to install rings. If you look carefully, you can see that the structure is actually sitting up on timber, and that's to allow a gap between the reline plates and the existing plates to be able to get that grout in between there and really lock that structure into place. On the right, you can see the construction crew is advancing quite nicely to the end of the culvert, and you can see there's bracing in place to hold the structure in place during assembly, but also during grouting. It's also important to keep that shape, because once you pump grout in there, again, as I mentioned before, you will get flotation forces and you want to hold that structure into place to make sure you get a good grouting operation. So before we move on to some other pictures of tunnel liner relines, I just want to highlight the different types of metals and coatings that we offer in our structural plates. Galvanized steel plate is obviously a very common material and coating, and definitely appropriate for those non-aggressive environments. But where durability is concerned and where the environments are slightly more aggressive, there is the option to supply a polymer-coated steel plate. This is our Stratacat coating. This is actually a baked-on powder coat, and the polymer coating is actually quite resistant to abrasion. So that's a very good option for when more durability is required. And we also make tunnel liner plates out of aluminum, which is great, as I mentioned, makes for really light plates. But it's also supplied in aluminum structural plate, which is similar to multi-plate. So aluminum can be provided in most shallow corrugated structural plates. So here are a couple of nice photos of some of the the odd custom shapes that we can provide with the tunnel liner plate, and highlighting some open bottom structures. And this might actually answer a question, one of the questions earlier. We can see on the right there, that's a structural reline of a cast-in-place concrete box. Excuse me. You can see it's not in very good shape, but we were able to come up with a custom-shaped reline with our tunnel liner plates. And because of the size of the plates are a little smaller than other structural plates, we have a lot more freedom to come up with a custom shape. And in that particular site, the shape we selected was such that we wanted to minimize, number one, the amount of the reduction in end area from the previous structure, and number two, you want to minimize the amount of grout that the contractor has to fill between the liner and the existing structure, and that just helps cost-wise. Just a few more photos of custom shapes. We've done ellipses, both horizontal and vertical. We've done some nice odd shapes there. You can see on the top right. Those tunnel liners are almost a triangular shape. Obviously the plates still need to have curves in them, but yeah, we've done nice projects where we tailor the reline to the existing structure. So we have a lot of freedom there. I just wanted to show you a case study. This is a creek reline in Huron County, Ontario. And the reline plate is a tunnel liner arch. And I just want to highlight the challenges on this site. A couple of the challenges. Number one, the existing cast-in-place structure was actually built with a bend in it. So you can imagine a little bit difficult to slip line a straight line pipe into a structure with a bend in it. And also hydraulic capacity was an issue. The existing structure was over capacity, and although cost-wise it needed to be remain intact and relined, some additional hydraulic capacity was required. So in the end, solution hydraulically was to add an additional pipe, and this pipe was actually another trenchless operation. This pipe was jacked into place. Number one, that allowed water to be diverted during assembly, but also gives extra hydraulic capacity during peak times. With the tunnel liner plate, to address the bend, tunnel liner being a segmental construction, it's actually quite easy for us to shop fabricate an elbow. And you can kind of see in this photo how the structure takes a bend. So it really doesn't impact, when it's being assembled from the inside, it doesn't impact construction too much, and very easily adaptable to structures with horizontal or even vertical bend. So just moving on from structural plate, I just want to briefly talk about corrugated steel pipe, because really the easiest way to reline an old pipe is to slide another pipe into it. So commonly in relines, we have supplied regular corrugated steel pipe, our Hellcore pipe, but we're really going to highlight our spiral rib pipe, which we call UltraFlow, and I'll show you why in a sec. So just a comparison between the two types of pipes. So the Hellcore pipe is a traditional CSP. It has a sinusoidal corrugation, but the UltraFlow pipe is a spiral rib pipe. And what this pipe is the rib in it is actually a 19 millimeter by 19 millimeter rib, and the rib is on the outside of the pipe. So the rib gives the pipe its construction strength and stiffness, but the rib being on the outside allows for a much smoother inner wall. So both these pipes would be assembled outside and slip lined and then grouted into place They can both be designed as a structural liner for relining, drainage pipes, and available in round shapes as well as pipe arch shapes. But really, why we focus on ultraflow and why it's much more common for relining is the fact that the smooth inner wall gives it superior hydraulic properties. So you can just see the view here on the interior, from the interior of the spiral rib pipe. You can see it is quite a bit smoother than regular corrugated steel pipe. And the pipe decades ago was actually developed to compete with concrete pipe. So it has the same type of smoothness or Manning's N of about 0.013. This pipe's available in diameters from 450 to 2,600 millimeter in diameter. And I just wanted to highlight a reline example using the smooth wall or the smoother wall spiral rib pipe. Let's say we were relining an existing 1,200 millimeter corrugated steel pipe with a smaller ultraflow pipe. We can actually achieve almost the same flow in ideal conditions if the pipe is flowing full. So the idea is that you're minimizing the effect on hydraulics going from a rougher pipe to a smoother pipe.
There's a question here about ultraflow.
Yep.
Does it increase the life cycle?
Well, in terms of the smoothness, generally when we're worried about abrasion, whether it's corrugated or it's a smoother wall, that you're still going to have issues with the coating. So generally, not a lot of increase in surface life. If we're talking about an abrasive or a water with significant bed load. A case study here. This is actually a triple reline located in North Van, BC. The pipes that were installed were a 1,200 millimeter diameter ultraflow pipe. And there were a number of challenges on this site. The existing pipes were very old and definitely needed repair. But being in an older urban area in North Van, open cut excavation was just not possible. And then there was also the issue of hydraulic capacity. And you'll notice that that comes up a lot in these challenges when you're relining. Anytime you're reducing the size of the new pipe, you're reducing your hydraulic capacity, so you have to be sensitive to that. So the one interesting thing on this, particularly interesting thing on this site, is that the engineer actually designed a beveled end on the end of the new pipes. So this was slip-lined into the existing pipe with an existing concrete head wall, but the pipes were terminated in from the outside, in from the edge of the head walls, and the beveled end sort of troweled in there for that beveled finish. And that actually helps improve the hydraulics of the culvert. It helps the water get into the culvert a little bit better than, say, if it was just a square end. Here's just a picture of the overall site with 3 pipes. So overall, a very successful reline in an urban area. So next, I just want to talk about the steel and the coatings that are offered in our array of CSP pipes. Galvanized steel, again, that's the most common type, particularly with our standard drainage pipes. Still good in typical non-aggressive site conditions, but a lot of times when we are talking about rehabilitation or relining, it's because the site conditions may be more aggressive than a galvanized pipe is appropriate for. So there is the option to supply an aluminized type 2 steel pipe. And what that is essentially it's a steel pipe with a pure aluminum coating. And the coating actually holds up very well because aluminum works a little bit more as a self-healing barrier coating as opposed to a galvanized zinc coating, which is more of a sacrificial coating. We also offer a polymer laminated pipe, and this is actually a pipe that it's actually made from a steel coil that is polymer laminated, before it's wound into the coil and shipped to our plant. So the polymer coating is on there before we actually corrugate and wind the pipe. So that definitely offers much more durability in terms of service life. Whenever you have a fully protected barrier between the steel and the environment, you reduce the risk of corroding the pipe. So the one thing to keep in mind with any of the structural plates or the CSP pipe coatings is that, if you're in a case where, abrasion or some kind of damage happens, once you lose the coating, then you have exposed steel, and then your service life is going to decrease a little bit. So that's why that seems to be a good point where we can switch gears for a bit and talk about plastic pipes or plastic products using, and we're going to focus on our trenchless or relining operations. So I'm going to talk about high-density polyethylene and polyvinyl chloride, or HDPE and PVC. And really, moving from coated steel to plastic, the biggest benefit is extending the service life of your pipe. Plastic pipe is basically immune to corrosion and also very resistant to chemical attack, particularly HDPE. There are not a lot of chemicals that can actually harm that plastic. Jet fuel is one of them, so don't be pumping jet fuel through your HDPE pipes, but for the most part, these pipes are supplied in some very nasty conditions in mining and oil and gas industry. So the pH range of the water flowing through these pipes is a very wide range, anywhere from 2 to 12. So from acidic to very alkaline conditions is not a problem for plastic pipes. Obviously, definitely a problem for a galvanized pipe. So, these plastic pipes are also very resistant to abrasion, and this is one thing that we like to highlight, particularly with HDPE pipe, because HDPE is actually the best pipe material in terms of abrasion. This has been tested and it actually comes out on top, better than PVC, significantly better than steel and concrete pipe. So it might be a little known, but definitely a good pipe to use in abrasive conditions. And another thing to note, when you consider a coated steel pipe, if it's abraded, you're going to lose your coating. Whereas if you do lose some wall thickness on a HDPE or PVC pipe, underneath it's just more HDPE or PVC. It's just more plastic. So definite benefits there. I also want to highlight the high strength to weight ratio of plastic pipes, and this is why it's very popular among contractors. It's easy to move, easy to lift into place. So we're just going to go through various products that we supply that can be used for slip lining and relining. Excuse me. First on the list is Boss 2000. This is our version of corrugated HDPE pipe, and this is actually one of our most common pipes sold as drainage pipes. But also can be used quite handily for a slip line installation, relining small diameter storm sewers and drainage pipes. The size range is between 1,000 and 900 millimeter in diameter, so it's a little bit limited in terms of sizes of pipes that can be relined, but still does a pretty good job. The one thing to keep in mind is that with a fully plastic pipe, the corrugations do get quite deep in the larger sizes, so that kind of increases your outside diameter and makes it tougher to fit into existing structures. These pipes are usually supplied with a bell and gasket joint or a bell and spigot joint. And the other thing to keep in mind is that the largest outside diameter will actually be at the bell. So definitely a decent pipe for when the project permits. But what we really want to highlight is DUROMAXX. DUROMAXX is actually a steel reinforced HDPE pipe. So this pipe is actually a helically wound pipe, similar to the way ESP is manufactured. And the seams are fuse welded during the manufacturing process. And the key feature of this pipe is that it has the inner wall, which is fully HDPE, and but it has steel ribs that are wound helically along with it. And these ribs, this steel, these are actually galvanized steel ribs. It's a high-strength steel, and it's completely encapsulated in HDPE. So it prevents the steel from access to the environment. So the steel is not exposed to water or oxygen, no chance to corrode. So we really consider this an HDPE pipe in terms of durability. So this pipe is available in diameters ranging from 750 to 3,000 millimeter in diameter. So when you're thinking about a 10-foot diameter pipe, that's a nice large pipe, particularly in a plastic pipe. The one nice feature about the steel ribs is actually quite a bit more efficient in terms of strength and stiffness than, say, an all-plastic pipe. Because when you get into larger diameters, if you're only using plastic, your only option is to put more plastic in the pipe. So you do tend to be a lot more cost-effective in larger diameters by using steel ribs as your reinforcement. So this particular pipe is also available in bell and spigot joints, sanitary rated joints for up to 1,800 millimeters in diameter, and also available are welded joints, particularly for large diameters. And these joints actually are quite good in terms of water tightness. And also, one benefit is that without the bell, you're getting a consistent outside diameter. So whenever we're talking about relines, we want to minimize that difference between the inside and the outside diameter. And that's one of the key features of DUROMAXX and why it's been really popular for slip lining and relining in both Canada and the U.S. 2 minutes? Okay. Okay, you can see in the photo on the bottom left there's an example of slip lining. I'm just going to quickly go through a case study here. This is a project done in Campbell River, BC on Vancouver Island. This is actually a DUROMAXX reline of an existing multi-plate structure, and being 3,000 millimeter diameter, it's actually the largest DUROMAXX reline in North America. The challenge on this site was the fish window, and I'm sure a lot of BC folks and even Ontario folks are aware of the challenges of doing construction in the water during the fish window. There's only a few weeks available. So this pipe was actually able to be installed, slid into place within a day, and then ready for grouting over the next few days. So a very quick installation. Contractor was ecstatic as to how well it went through. There's just another photo of the contractor lifting and sliding the pipe into place. Okay, quickly just coming to the end here, I want to highlight a PVC pipe option, an A2 liner pipe. This is actually a corrugated PVC liner pipe and specifically designed for relining, particularly because the profile of the corrugation is actually very small, so it really minimizes that outside diameter. This pipe is commonly used in sanitary sewer relines because of its versatility there, available between 300 and 900 millimeter diameter. Custom lengths are available as well. A lot of times a reline has to happen from a manhole, so smaller lengths that are capable of being lowered down in the manhole and then rotated and then sliding the pipes. Those are also options. So just a couple of close-up pictures to show the joint. Definitely a sanitary rated joint. You can see that it's designed to have a consistent inside and outside diameter, which really helps for slip line. But the pipe is truly developed for relining, and particularly the joints, because they are actually quite capable of pushing pipes, long lengths of pipes up to about 1,500 feet in length, down the existing pipe without hurting the joints. Same idea when we talked about going from a rougher pipe to a smooth pipe. This is a very smooth inner wall on this PVC pipe with a Manning's N of 0.009. So you could potentially, even though you are reducing the diameter of the existing pipe, you could potentially achieve the same flow characteristics as you had before. And almost lastly, I just want to point out bring to the attention some new technology called spiral wound pipe. And what's really interesting about this technology is actually designed to basically manufacture a pipe down inside a manhole. So it's designed to basically go from manhole to manhole and reline an old pipe by actually making the pipe, winding the pipe in place, and advancing it along to the next manhole. So just quickly, a couple of the technologies that are probably most interesting. SPR-PE is a steel reinforced HDPE liner. Essentially the same as the DUROMAXX pipe that we talked about. However, being able to be manufactured down inside the manhole. So that's definitely an interesting type of installation. The pipe is continuously welded in the installation and creates a seamless pipe going from manhole to manhole. And almost lastly here, SPR-EX is a PVC type liner. And the interesting feature about this liner is that it's actually, when it is wound down inside the manhole and advanced along, it's actually wound to a smaller radius than the existing pipe, so that once it's in place, mechanically it's actually expanded into place. So it's a self-expanding PVC liner. So it can expand to fit the inside diameter of the hose pipe, but also able to fit around various changes in elevation or alignment. And lastly, INNERFLOW is a solid smooth wall HDPE pipe. So in terms of pipe, solid being a solid wall, it's very similar to typical SDR pipes. It's very robust, and it has a male-female interlocking jointing system, which is a very strong joint. Also sanitary rated, but very strong in terms of being able to use the advancing pipes to jack or slide the previous pipes into place. Definitely a premium pipe, more of a brute force method to relining an existing structure that might be in distress. So just lastly, to summarize everything we've been talking about, we have a wide variety of products that can be used for tunneling and relining and rehabilitating. And really, the basic criteria in selecting what type of product will involve, what size and shape is required. Hydraulics, we talked a lot about hydraulics, and that's definitely one of the key factors. Durability is also a decision factor there in terms of service life and abrasion, and that will help determine whether steel is okay or whether you need to deal with HDPE or PVC. And constructability also, you could be dealing with a site, say a pipe is so long that slip lining is not an option. Well, maybe being able to assemble from the inside is a benefit there. And of course, cost is also a big factor in decision when selecting the right product. So that just about wraps everything up, and I think we'll move on to questions.
How far can the spiral wound pipe go?
Okay, yeah, I figured that spiral wound might get some people's attention, because it is a really new technology, and really, I mean, it's neato as far as I'm concerned. But, in terms of how far, it's designed to go from manhole to manhole, so it's definitely designed to go from standard manhole spacing. But there are methods to help the pipe along by pulling from the other end. So definitely for most applications, definitely it's a possibility.
Does Federal Fisheries have preferences for ultra-flow versus other types of pipe?
Well, a lot of times when we're talking about fishery or fish-sensitive waterways, we're definitely moving towards open bottom structures. So a lot of times replacement is more the way to go. But in terms of what pipe is used, whether it's galvanized or plastic pipe, in a closed bottom or full periphery structure, I don't think there's a preference there.
How do I size a reline pipe when inside an old corroded buckle pipe?
So one of the first things that needs to be done is a survey of the existing pipe. And we've come across this on many occasions. You have to be careful when you have a pipe that has deflected or buckled. Your new pipe has to fit inside along the length. So usually the process is to get a good survey so we can figure out what the maximum size that we can fit along that alignment is. And that's usually working with the engineer or the contractor, and then working with us to help select the size.
How do you seal connected areas to keep the water from inside the tunnel? And that was for multi-plate.
Keep the water inside the tunnel for when you're relining. These structures are not designed to be waterproof, as in like a structural plate. If this question is referring basically to a very runny type of grout, I would be a little careful there. Basically, if you're relining with a CSP or a BOSS or even the PVC type product, there are no concerns as far as the water staying inside. From a structural plate point of view, if the water is running through the structure and you are grouted on the between the two structures, we're not concerned about the water. The only reason I mentioned about the plates, structural plate, is that we've seen a few grouts out there that are very, very almost the consistency of chocolate milk, and we're a little concerned with the waterproofing. Again, these structures are not waterproof.
How do you know when the grout fill is complete? Is that due to some kind of pressure gauge?
Typically, the grout plugs are placed at 12 o'clock, 3 o'clock, and 9 o'clock, and you will grout in lifts. And the last lift would be the upper lift. So you would plus you're going to have some vent holes at the top of your structure being grouted. The what I'm going to call the host structure. So the grout will come out of the vent tubes, and then you will know. Now, sometimes I've had guys inside with a little hammer kind of tapping along, because you can tell where there's voids and where there isn't voids. But there is a certain amount of pressure to the grout, and again, the vents will act in that way that the grout will be coming out of the vents, and then you'll know that the structure is fully grouted.
The original structure has voids in the backfill. When it is relined, are the voids filled by the grout as well?
Yes. Two things to watch out for with that is if the voids are large, and I'm talking large where the bottom of the structure, it might be the host structure is rusted out, and there's like, I would fill some of the voids prior to relining as far as, the really bad ones. But if there's any voids in behind that you can't see, yes, there's enough grout pressure on the pump that it will fill the voids in behind as well. But again, if there's large gaping voids, fill those voids first as best as you can before you put the liner in.
Can an individual sheet be repaired or replaced?
Absolutely. That's the beauty of the tunnel liner plate, is that plates can be taken out and put back in. After you undo the bolts, and that there may be a little bit of prying, and maybe to get the old plate out, you may cut it with a hot saw or a torch if the plate needs to be replaced anyways, right? But with all of our structural plate, actually, plates could be replicated and replaced, yes.
How does it self-expand?
The seam is actually an interlocking seam with a gasket, so it's not fuse welded on this pipe. So it's mounted to a smaller diameter than the existing pipe. And there's actually a tab that can be broken, and that tab is what is holding the pipe to the smaller diameter. So there's actually a machine that pulls a wire from the pipe that actually breaks the tab along that seam, and then that's how it triggers the expanding into place. So it's kind of it's wound and it's sort of spring-loaded and held by a plastic tab and then mechanically broken to expand that pipe into place.
What are the cleaning and scaling, descaling requirements of various pipes?
Cleaning and scaling, as far as for like a CSP reline or even a concrete reline or whatever, basically get as much of the junk and the garbage out of the pipe, of course, and anything loose I would remove from either the pipe or the hose structure, or we've even relined concrete structures where they've put pieces of plywood to keep the infill from falling in or from the grout from going out. But again, just basically, yes, you do need to clean the pipe. You need to clean the garbage out of the pipe. You need to clean the invert so the pipe is nice and clean.
How is the grouting done when the structure is too small to fit a person?
Well, there's various ways to do that. Actually, I was on a call the other day about that. It was a 24-inch pipe that was being relined, and so typically what you could do and what the guys do is slip line, bulkhead up the ends, and then cut some small holes in behind the bulkheads and pour the grout in through the hose structure. Now, if it's really long, you can do one at each end, and of course you're not going to excavate the road or anything, but yes, cut a hole in the hose pipe after you've built your bulkheads to keep the grout in, and then just either pump or just flow the grout in.
So upcoming monthly webinars, you can find them at armtec.com/webinars. Definitely make sure you join us on social media, and we're on all the regular channels. You can go to armtec.com. You'll find up at the top right corner opportunities to join us there. And here's our contact info for Patrick and Dave. That's it for today. Thank you very much.
Thanks, everyone.
Thanks, guys.